What the hell? What the hell? The hell?
Browser is interactive.
In this video, I'm going to share with you guys exactly how I made almost $10,000 from bug bounty at the age of 16. Video, so welcome to my channel. I'm going to mainly be posting cybersecurity content here, so make sure you subscribe to support the channel and to stay tuned for more. And for the introduction, my name is Charles. If you're here from Twitter, you know me as ErgoSum. I'm 16 years old, I'm a high school student, and I'm passionate in cybersecurity. This video is going to be broken up into 3 parts. The first 2 are going to be my kind of onboarding and how I was learning and stuff, and the last part is going to be mostly about bug bounty. So to start off, we're going to be starting in the year of 2022. I was mostly on Discord. That was the main thing I was doing on my computer, Discord and like video games. And I like to play Counter-Strike. And the more I played Counter-Strike and watched YouTube videos on it, I discovered this whole community of gamers called hacker versus hacker. And it's pretty much what it is. It's people that are hacking in the game going against other people hacking in the game. But with my interest in it, I would be on YouTube looking for more content on the game cheat. And the more I did that, the more that I figured out that there's a whole community of game cheaters. More so that there's a whole community of game cheat developers. And when I watched these videos of these developers coding these programs, it was just astonishing. And I was like, I could do that. That isn't too hard. That was pretty smooth and cool. So if you've ever tried to make your own game cheat, you probably found the video where the dude tells you how you can use cheat engine to find like the memory addresses of like the game's ammo value and damage values and stuff. And then you could create a program that like overwrites those values to something that's not supposed to be. And then you inject your program into the game, and then you have unlimited ammo, unlimited health, unlimited damage, and it'd be super cool. And I soon realized that there were levels to this program and stuff because I could not do it for the love of it. So I decided, well, how about I get into a different side of programming? Because I had also used forums like OG users, and I saw that these people would create these like Python programs that would like claim a username is the second it gets changed. And that's what kind of introduced me into Python. So I searched up a YouTube video and I watched like the free code camp and learned how to make variables and print out stuff to the console. I learned about the data structures and if statements. And I got a pretty good foundation for programming syntax, or at least programming fundamentals and techniques and that sort of stuff. But I found that I never could really make anything too unique or make anything that was not just a program that makes some network requests and prints out the response, or a Discord bot, just those things that are not so hard to make or require some complexity to make. I never really got into the networking side of things, like socket programming, where I could make a chat server or something like that. I just couldn't do it. I could not do it. And that led me into learning about web development and specifically front-end development. So I rinsed and repeat the same thing, went on YouTube, searched up how to make websites, and I found a course on HTML, CSS, and JavaScript. Learned how to do that, and I started making little websites. And those projects gave me that like rush of, creating something new that I thought was unique, but in reality it's not. It still felt good to do it. And I even moved on to the JavaScript framework. So I was learning how to use React.js and Next.js, and that really leveled up my skills because I could make like modern websites that have complex functionalities, and they have multiple pages, and they have animations and cool styling. And once I made my first portfolio, I was like, wait a second, I can fit in with the cool Discord kids now. And I soon realized, there's just one difference. They have money, I don't have money. So I was like, how do I get money? Well, I have a skill of development. So I went to the OG users forum and I created like a little thread saying, hey, I can freelance and create you a website in Next.js or React.js. So I got some clients and I was making decent money. I only got like 6 clients with multiple projects for each of them and got pretty good money. But I ended up stopping this. And the reason I stopped is because I was addicted to drugs. More like a drug, I was addicted to the THC cartridges, so I could just vape weed in my room. And I thought it was like a cheat code because it's really convenient. So I could get home from school and sit down at my desk, smoke weed without nobody knowing in my house, and then go and code and make a bunch of money to buy more weed. But doing that actually made me lose motivation to code because it was like an intellectually stimulating activity, not like a quick dopamine hit. It's a long dopamine hit. And it led to this one night where I was on Discord, went in the server, and there was somebody in the voice chat. And this person had the username of Sleep the God. Now, I don't know if anyone watching this video knows who Sleep the God is, but if you do, I'm not trying to hate on him or anything, or even talk about him or go in depth about anything he's done. I'm just going to tell you guys, yes, this is the person who got me into cybersecurity and got me to where I am today. So yeah, I was in the voice chat and he was screen sharing and he had like Chrome open with a billion tabs and he was on like these government websites and he'd be on the pages called like ArcGIS, maybe I'll edit ArcGIS, and it's like a weather application, but there was really not any functionality that was not supposed to be a functionality. But I made sure to add him at the end of the night and he sent me a message which included the word pen testing. I searched it up and I discovered the topic and the idea of ethical hacking. And we've now made it to the second part of this video, ethical hacking. So I want to give you guys an insight on how I learned what I know now because it really wasn't anything special. So I learned about cybersecurity and I learned about the offensive side of things where you're the one breaching into the network. And I learned about a platform called TryHackMe. I completed the foundational courses and stuff on there and got pretty good at using Linux. And I learned about networking, so I knew what an IP address was. I knew what a VPN was, that sort of stuff. And after learning all those foundational things, I started to compete in CTF. So CTF is an abbreviation for Capture the Flag. In cybersecurity, a Capture the Flag challenge is pretty much like a system or a web app or application that is intentionally broken. But the trick is there's a puzzle that you have to solve and you have to beat this puzzle and reach a certain level of privilege on that system or application in order to get the flag submitted and win the challenge. And I was pretty bad at the start. You know, I really didn't have any good enumeration skills or anything. And I knew that there was like solutions or write-up to the machines. There was write-ups to the machines. And when I felt too stuck, I would go on the solution and write up and figure out what I was missing. And this is, I think, how I improved so fast at the Capture the Flags. And I just rinse and repeat that. I would just rinse and repeat, write up, learn, and complete. But, you know, I wasn't too persistent with it. And you probably already know why. It's because of drug addiction. So I ended up dropping the whole TryHackMe thing and never branched from that. But around late 2023, when I made the decision to get sober, I started to realize, hey, I need something to do. And not just something to do, but something to give me like a purpose. And I got back into the cybersecurity. I was starting back up on the CTFs, kind of warming back up into my little zone. And I also created a Twitter account. And yeah, you know, it's pretty much the same story as before. I was improving by doing CTF, cranking up the difficulty, learning when I got stuck, and I ended up moving over to Hack the Box. And I found this like penetration testing specialist course. And I was like, oh my gosh, this looks really good and like juicy and there's so much information. And then I went to the billing part and I was like, oh my gosh. But when doing more research, I figured out that Hack the Box Academy had like a educational student benefit plan where for $8 a month, I could get access to that whole penetration testing specialist course for completely free. But I did have to pay the $200 to complete the certification that comes after you complete that course. So from like the beginning of 2024 to about maybe a month or two before summer, I finished that whole entire course. So to further improve my skills there, I did the Zephyr Pro Lab on Hackabox. But the reason I even attempted it is because on Reddit, I saw that people were comparing the Pro Labs to the CPTS exam environment. And I was like, okay, well, I used a C2 framework and I got through these. I could definitely beat the CPTS exam. And then I remember the CPTS exam voucher is $200. And this is when I discovered Bug Bounty. And I tried out my first Bug Bounty program. I lasted like 1 day on it and found nothing and just thought, no, this is too hard for me. During late 2024, I ended up circling right on back because I had saw another 15-year-old who found a bug in Zendesk and got like $50,000. And I was like, okay, no. So I did more research. I went on YouTube and I found a video from Nahamsec. I went about like choosing programs and how you actually need to do it. And I ended up landing on a financial technology company. I started hacking them in like early December. And by maybe like a week or so in, I ended up finding a really cool vulnerability. Because of the program rules, I can't really talk about it too much, but I'll put it at a really high level so that I'm not really exposing that. So basically, I had done like Subfinder and HTTPX to find some websites to hack on. And I came across this one website where it was kind of like invite only. Like you couldn't register without them allowing you to register. But I was looking at the HTTP request and I saw that there was a backend going on. And the backend wasn't normal because this was like a React.js app or something like that. And I could see that there was like some backend routing going on. And when poking at that routing, I figured out this is a content management system. And because of my experience with CTFs, I had already known that this content management system has like a certain way of showing the pages. So I used that knowledge to have a look and see if this backend was exposing any pages. And when doing so, I ended up finding that it did, and there was some personally identifiable information on those pages. So I coded up the script, grabbed all of it, and I showed the impact to the program, and like I also combined it up to a low-hanging fruit to just make the impact really good and whole. And I got $1,100 for it. And I was really proud of myself. But because of how fast I found the vulnerability and how much it was, I was like, hey, I can do this. After this vulnerability, I really got stuck. And I was like kind of doubting myself. After a break from the Bug Bounty, I came back to the same program with a bit more refined reconnaissance strategy. So I just used the context of the company. I knew how old they were and I knew how big they were. And I used that information to discover some subsidiaries. And when doing reconnaissance, I ended up finding a really, really critical vulnerability, which I'm not even going to go in depth about. But I landed $7,000. And this was the craziest moment. I mean, probably one of the craziest moments of my life. But after making these money from the Bug Bounty, I was like, hey, I got some money to invest back into myself. And I ended up taking and passing the CPTS certification at Hackabox. I love that because that was like my whole thing. Like I was really, really obsessed with that certification. I was really proud that I could prove to myself that I was a certified penetration testing specialist. And yeah, so I also landed another bounty recently, which was $900, which was a cross-site scripting vulnerability that I reported a while ago. And that bounty is what amounts all my earnings to close to $10,000. So that is not clickbait. But yeah, guys, that's mostly it. I made this video because I wanted to share my story. I don't want people to think that success just comes to people who are lucky. I want to give an example of how me, who used to be addicted to drugs, smoking every day, not really doing anything with my life, was able to bounce back from that and be persistent enough to achieve the stuff that I've achieved in about a year of practicing cybersecurity. Because if I can do it at 16 and other bug bounty hunters can do it at 19 and 18 and like as young as these people are, making millions of dollars, like literally, then you can do it too. I'm not saying that it's easy, but it's possible. It's a journey with yourself, and it's a journey about finding purpose. But, when comparing yourself to others, all that confidence kind of goes out the window. So don't compare yourself to anyone. That wraps up the video. I hope that you guys learned a bit more about me. Please make sure to subscribe to support the channel and comment down below any questions you have for me, because I don't mind answering them. But that's all. Have a good night and goodbye. In this video, I'm going to be reviewing the CPTS certification at Hack the Box after I passed it at 16 years old. If you're a returning subscriber, then welcome back to the channel. I hope you're having a good week. So for this certificate review, I'm going to
Are you ready to play with some malware? Whew, gotta be careful, because in this video we are talking about dangerous things, malware or malicious software. And disclaimer, this is for educational purposes only. Sure, learn it, play with it, go crazy with it, but never use it for malicious purposes. In this video, we're doing two things. First, we're gonna write our very own ransomware in Python. Yeah, and it's awesome. I can't wait to show you. And also, it's kind of scary how easy it is. Like, really scary. Don't worry, you'll see. And then second, we're actually gonna download a malware library. It's literally a bunch of malware that we can play with. It's written in Python. We can do things like worms and trojans and spyware, adware, all kinds of stuff. So, get your coffee ready. Let's do this. Now, before we dive into this craziness, what do you need? First, you'll need a Linux computer or Linux server, and preferably one you feel comfortable blowing up, like obliterating it, because you're going to be installing malware and running it. Now, the good news is that this is crazy easy thanks to our sponsor, Linode. Let me show you real quick. I'm going to set up my Linux box right now. I'll navigate out to linode.com/networkchuck, link below. Now, here in Linode, I'm going to set up my Linux server in the cloud, and it's only going to cost me 1 penny per hour. Like legit, that's it. 1 penny. And it's crazy easy to set up. So first of all, get signed up if you don't already have an account. And by the way, if you're new, you get a $100 credit for the first 60 days, which means this will be free for you. And watch how fast this is. Create. Linode. Our image, we're going to do Ubuntu. 2204. Region, something close to me. Plan, shared CPU. Linode, 1 GB. Name it, password, and create. So right now I have a Linux computer that is baking in the cloud. It's going to be delicious. And while I'm destroying it with malware, again, it'll cost me 1 penny per hour. And once I'm done, I'll just go over here and delete it. I love how simple this is. This is why I use Linode for my labs and also my business. Look at all these Linodes I have in my business right now. It's kind of stupid how many I have. So back to our list, a Linux computer is easy with Linode. But if you already have a Linux-based computer that you're willing to destroy and blow up, use that one. That's fine, that'll work too. And the second thing you'll need is, you need coffee. Everything in IT requires coffee. NetworkChuck.coffee. Okay, step one, let's access our Linux box. Here in Linode, I'm just gonna copy my SSH root command here, fire up command prompt here in Windows, it'll be terminal in Mac or Linux, paste that command, accept all fingerprints, put in my password, and we're in. So our first task is we're actually going to write some ransomware in Python. Now, this is going to be crazy because ransomware is one of the most dangerous and devastating malware out there. It's taken down companies, even companies I've worked at. We spent like days and days trying to recover from malware, ransomware attacks. Because what it does is, let me show you. It'll take files, any file, and it will encrypt them or lock them up. And the only way you can access your data is if you have the key. That's my key. I'm sorry, it looks terrible. But the problem is that you don't have the key. The ransomware will go through pretty much every file it can access, which in a lot of cases is like every file on a server or a computer or a network, and it will lock it up. And what will happen is they'll say, hey, we'll give you the key, but you got to give us some sweet, sweet cryptocurrency, some Bitcoin, some money. And once you receive that, we'll give you the key to unlock your stuff. Scary, right? Happens all the time. So why not make our own right now? Let's do it. Before we start writing some code, let's go ahead and create some files that we can attack and encrypt. So let's make a new directory, mkdir, here in Linux. We'll name that sucker ransomware, bam, and then we'll jump into that directory by doing cd ransomware. We're there. And let's create like 3 or 4 files. So we'll do echo, this is a file, and we'll output that with our directional arrow to a file, file.txt. Let's do another one, and one more. Done. Another one. So now if we ls our directory, We see our 4 files there. If I cat one of those files, like let's say file.txt, I can see they do have content inside that we can read, data untouched, unencrypted. And now let's hold them for ransom. Let's encrypt those suckers right now. Here we go. So now let's start a new file, nano, and we'll name this Voldemort.py or py. Bam, we've opened our file and now we're ready to edit our code. First, shebang! Did I scare you? That's our shebang, by the way. If you're like, what the junk is that? I got a video right around here somewhere you can watch and learn about it. Now, our first goal in our script is to find all the files in our current directory so we can encrypt them. So we're gonna find all these files and we're gonna add them to a list. I'll start with good documentation. Coffee break. Oh, and also we have to import something into our script. We're going to import the library OS. So add that at the very top. First, let's define our list. Files equals empty list, opening and closing brackets, just like that. Then we're going to use a for loop to discover all the files in our current directory. This is really cool. Watch this. So we'll say for file in os.list dir, open and closing parentheses. And notice we're using our OS library right now, which let me show you how that works real quick. You can follow along with me if you want. I'm gonna go ahead and just save this file, Control X, Y, enter. I'm gonna jump into Python real quick. Right here in the command line, Python 3, I'm in. I'm going to import OS, and I'm gonna run that command that we just were about to use in our script. So os.list dir, open and closing parentheses. Watch what happens when I do this. Bam. And this is exactly what we want, our targets. So let's get back to our script. So for file in os.list directory, colon, enter and tab. And by the way, if you're unfamiliar with for loops, all this is doing here is just literally going to go through every file that it can find in the directory, our current working directory, and do something with it, which in our case, we're going to add each of those files to this list. But there is a problem here we have to solve. We don't want to encrypt the file we're working on right now, Voldemort.py. So we do not want to add this current Python program to the files list because we're going to encrypt and destroy all that stuff. Quickest way to solve that is with an if statement. So we'll say if file equals, and we'll just say the name of the file, Voldemort.py, colon, and then we'll tab, give some space there because space is important in Python. If you don't put the space there, it's going to hate you. I'll just type in continue, meaning move along. Don't do anything with this. And then we'll hit enter and then tab once more. We'll call the list files, and we'll use the append method, APPEND, and we'll add file to that list. That should do it. So this will literally go through every file in our current working directory and add that to our list. Let's try it out real quick. And actually, to verify it's actually happening, we need to, let's go ahead and print at the end of this, print the list files. Cool. So Control X, Y, enter, save. And to run our script real quick, we'll do Python 3 Voldemort.py. Let's see what happens. Look at that. Totally worked. Every file is part of that list except for the most important file, our Voldemort ransomware. Now there is one more problem and I want to show you real quick. Here in our directory, I'm going to actually make another directory. I'm going to mkdir test. So now if I ls, I can see we have 5 files and a test directory. If I run that script again, Python 3 Voldemort.py, look what happened. It added our files, but it also added our directory. We don't want that. We only want to encrypt files, individual files. Let's fix it real quick. It's actually a pretty easy fix. Let's jump back into our script. And here, before we add a file to our list, let's add another check. Let's add another if statement. If os.path.isFile, we'll do open parentheses and we'll put in file, colon, then do something. So here with our OS library, we're actually using a built-in function to determine if one of the things in our directory is a file or not. If it is a file, boom, let's do something with it. So let's go ahead and do that. I'll hit colon, enter, tab, tab, and here is where we'll add our files to the list. So we'll call our files list, files.append, add file. So now a file will only be added to our files list if and only if it's not Voldemort.py and it is indeed a file and not a directory or anything else crazy. Let's test it out real quick. Control X, Y, enter to save. Let's run the script. Bam, that directory is not there anymore. Perfect. Now it's time to encrypt those files. So let's get back into our Python script. To encrypt the files, we're going to use a cryptography library that we're going to need to import here at the top. So go ahead and go up to the top of your script and type this in with me. From cryptography, I never can spell this right. I have to like really focus. Cryptography, I still did it wrong. There we go. .fernet, I'm not sure if I'm saying that right. Whoa, that was hick. Fernet. I'm from Texas, by the way.
If you've been thinking about a degree in cybersecurity or IT, check out UMGC. Low-cost tuition, 100% online classes, and they teach you how to apply the AI tech everyone's talking about.
It comes out every once in a while. So from cryptography.fernet, import capital F fernet. Fernet is a very cool way to encrypt things in our Python script. Actually, Professor Bernard, go ahead and tell us about it.
Fernet is a symmetric encryption method which makes sure that the message encrypted cannot be manipulated/read without the key. It uses URL safe encoding for the keys. Fernet also uses 128-bit AES.
Okay, Bernard, that's enough. Dude, you're putting them to sleep. Anyways, let's play with it real quick. First, before we can encrypt our files, we need to create a key that we can use to encrypt them. So, using fernet, let's create a key. Let's create a variable called key. Crazy, right? Key equals, and we'll use fernet. Fernet.generate underscore key, opening, closing parentheses, and that's it. And let me show you what it looks like. We'll test it out. So let's go ahead and print the key. Let's Control X, Y, enter to save. Let's run our Python script. And there it is, our new shiny key that we can use to lock up our files. So let's use it. Let's get back into our script. Now with our key, we don't want to print it out because then that'll just give the user the key. And no, we want to have them give us money, right? But we do need to save our key, right? We want to be able to unlock the files later. So let's go ahead and save that key to a file. For that, we're going to do this. Type in with, and then we're going to create a new file and write to it. So we'll use the open function, open. Then we'll do open parenthesis, and I'll create my file name with double quotes. I'll say the key. Dot key. Closing double quote. Then I'll do a comma, and I'll choose my mode I'm going to open that file in. For this one, I'm going to do WB for write binary. Normally, this will be just W for write, but we're using binary for this one. And then closing parenthesis, and then I'll say I'm opening this as, I'll just call it the key. So if you're new to opening files and writing files and reading files in Python, what's happening here is we're using the open function to create or just simply open a file called the key.key. We're going to open it in a specific mode, which is write mode, and we're going to refer to it right now in our function as the key. Let's try it out real quick. Hit enter and tab, and all we're going to do is say the key dot write, and we'll write our variable key. So remember, this is how we're referring to this file as. We're saying, hey, this file is actually called the key when we're working with this. We're saying the key, I want you to write something to it, and we're going to write the variable key, which we define right here. It's our key, right? So right. So let's test it out and let's make sure it works. Control X, Y, enter to save. Let's run our script once more. Python 3 Voldemort Pi. Bam. If we hit ls, we should have a nice new shiny file there, the key.key. There it is. And if we cat that file, cat the key, there is our key. Now we have one problem here that we have to solve though. The next time we run our Voldemort.py script, what's going to happen to our key? Like we saved it as a file here. What do you think Voldemort's going to do to it? He's going to encrypt it, right? He's going to encrypt the key with the key. We're kind of getting into like an inception of encryption here. We can't have that. So we need to tell Voldemort to ignore our key file. So let's jump into our script once more. Let's tell him in our filter over here, just after we tell Voldemort to ignore himself, let's say or file equals the key.key. Cool, that should save us. We should be okay with that. So we have our key. We generated it, we saved it to a file. Now let's lock up some files. We're gonna use the with open command again, except with all the files we're gonna destroy. But we're gonna do it with a for loop. So here we go. This is gonna be really fun. It's so cool. So for file in our list files, which we defined up the top. I'll do colon, enter, and tab. Let's do things to it. So here we'll say with open. So every file in that list, we're gonna with open it. The name of it is gonna be file, and we'll open it in read binary mode. Then closing double quote, closing parenthesis, and we'll open that as the file. Colon, double tab. And now we're gonna save the contents of that file to a variable, and we'll just call it contents. We'll have that equal the file.read. That's literally all we're doing. We're saying, hey, the contents of whatever file we're opening right now, save it to that variable contents. And we're using the read function on that file, or the read method rather. Now that we've opened it, let's encrypt it. So we'll set a new variable. We'll say contents underscore encrypted. And we'll have that equal, here's where we actually encrypt the data. We're gonna use fernet, so type in fernet, and in parentheses, we'll reference our key. This is the key we're gonna use to lock it up. And it's gonna be our key variable, the one we had set earlier, right up here when we generated the key. And then we'll do dot encrypt, and then we'll, in parentheses, reference the content, which we set as the variable contents. So this is this guy right here. Now, if you're new to Python, this is probably getting a bit hairy for you. You're like, hold on, what's happening? It's okay. Pause the video, rewind, or maybe check out my Python course right around here somewhere if you need to kind of brush up on some things. Okay, so we've opened up the file. We encrypted the content. Now we need to write that encrypted content back to the file. So we're gonna, again, do with open. We're gonna open up that same file, but this time we're gonna open it as write binary mode because we're now writing something to it. Close parenthesis, you'll say as the file, tab, and we'll say the file dot write, and we're gonna write contents underscore encrypted. which is the variable that we set right here when we encrypted the content. So this for loop right here should go through every file in our list. It'll open it, encrypt it, and then write it back to the file as an encrypted file. And at this point, it's done. Like, it's gonna do it. So let's save our file. Control X, Y, enter to save. And so let's say goodbye to our files real quick. Let's like cat the file.txt. Right now he's just, this is a file. He says stuff. It's not encrypted. Now let's run our file or our ransomware. Python 3 Voldemort.py. Goodbye, buddy. Now some things have happened. Let's cat that file again. Cat file.txt. Whoa. Encrypted. What was this is a file before is now just gobbledygook. It's nothing. Your files are locked. Can't get them back, sucker. Actually, we're gonna write a decrypt file right now. But as of now, that person's screwed. Now we do have the key. Cat my key. Or cat the key. That's the key to unlock it. I'll show you how to unlock it right now. Whew, so take yourself a quick coffee break. I need one. And the good news is that the decryption script you're going to write is very similar to the encryption script. So similar that we're just going to copy it. So right here in our terminal, type in CP for copy. We'll say Voldemort, and we'll copy it to a file. We'll just call it decrypt. Decrypt.py. And let's jump into that file. So nano decrypt. And obviously we're gonna have to make some changes to it. The first bit is totally okay. We're still gonna find the files. We're still gonna add them to a list. And we're still gonna ignore the files we don't need to mess with. Here are some things we're not gonna do though. First, we're not going to define a new key and then overwrite it. No, we're not gonna do that. So let's take out all that code, but we are going to need that key to unlock the files. So we're gonna have to open up that key file and set it to a variable. Let's do that right now. So we'll do a with open. We're gonna open the key file. So I'll specify that with double quotes. It's called the key.key, and we're gonna open that in read binary mode. I'll open it as key, and then we're gonna set a new variable. I'll call it secret key, and I'll have that equal key.read, open and closing parenthesis. So what we're doing here is we're opening our key file in read binary mode, and we're gonna refer to it as key, and we're gonna say, hey, we're gonna set a new variable, secret key, and have that equal the contents of that file. So now we have our key and our script. It's the key variable, or secret key variable. And with our key loaded, we can now unlock it. And really, we only have to change one thing over here. We're still gonna use a for loop to go through all our files. We're still gonna do that first step where we open the file up and read it. But right here, when we encrypt the content, this will be different. So let's scroll over to our contents encrypted. I'm gonna change that to contents decrypted and have that equal to for net. And we're gonna change the key to secret key because that's what we set our variable to. This matches this right here. And then instead of saying encrypt, we're going to say decrypt contents. And then we'll write those decrypted contents back to the file, which we need to change that variable from contents encrypted to contents decrypted to match. Perfect. That should do it. And before we test it, there is one thing we have to do. We've defined a new file in our directory. We have decrypt.py, which is another file that we have to ignore in our script or things will break. So up here in our filter, let's add one more or just after the key, file equals decrypt.py. Cool, so that should be ignored. Now we can test it out. So Control X, Y, enter to save. Let's verify our files are still encrypted. Cat file.txt. Yes, it's still gobbledygook, but now let's unlock it. Let's do Python 3, decrypt.py, and here comes the magic. Let's see if it worked. Let's cat that file once more. Yes, it unlocked. How cool was that? We encrypted a file and now we decrypted it. Does that not get you excited? Coffee break for you. Man.
Want to break into cybersecurity but don't have experience? The Google Cybersecurity Certificate uses real-world scenarios to teach you technical skills. You'll be able to step foot in your first job and feel comfortable and confident in the skills that you've learned in this certificate. Enroll today.
So fun. Now we're not done quite yet because we did the bones, the structure of how we do ransomware, but let's add some fun to it to make it seem like actual ransomware. So let's get back into our Voldemort file. Nano Voldemort.py. Now first we need to add our filter for the decrypt file so it doesn't decrypt our decrypt script. So we'll do or file equals decrypt.py. Let's just add some fun print language here. Like at the very end of our script, we'll say print all of your files have been encrypted. Send me 100 Bitcoin or I'll delete them in 24 hours. Done, done, done. Cool, so Control X, Y, enter to save. Right now, let's just verify real quick. Let's make sure all our files are decrypted. Let's do catfile2.txt. Looks great. Catfile, or no, we'll do please don't hurt me. All decrypted. Now let's encrypt it again. Let's run our Voldemort file, or script. Here we go. All of your files have been encrypted. And actually, at this point, we set a new key too. So let's cat those files again. They're encrypted again. So cool. And now let's add a bit of fun to our decryption file. Let's jump in there, nano, decrypt. And let's make them have a secret password that they have to enter for the script in order to decrypt their files. And we'll do that with a simple if statement. So first, let's set a secret phrase. We'll say secret phrase equals, obvious, right? Coffee. And then we'll ask them to enter the secret phrase. So we'll create a new variable called user phrase, have that equal input, enter the secret phrase to decrypt your files. I'll do a \n to give some space there, make it look pretty. Close that input statement out. So here we set a secret phrase. It's coffee. Then we're asking them to enter a secret phrase. Now let's evaluate it. We'll use an if statement. If user phrase equals secret phrase, then you know what we'll do is we'll nest our decryption underneath it. So let's back that sucker up, tab it underneath. We'll actually have to tab everything over once to make it look like so. Because again, spacing is extremely important in Python. So now, with our new script, their files will only be decrypted if their secret phrase, which is the user phrase they enter, matches our secret phrase, which is coffee. So let's try it out. First, I'll enter a wrong one. Actually, hold on. I want to give them the congratulations at the end if they get it right. I'll print congrats. Your files are decrypted. Enjoy your coffee. And then I'll do an else. Print, sorry, wrong secret phrase. Send me more Bitcoin. Cool, that should do it. All right, Control X, Y, enter to save. Our files are still encrypted. Let me just check. Yep, still encrypted. Clear my screen. Let's run our decryption file. Python 3, decrypt.py. Enter the secret phrase. Let's get it wrong. Let's do like T or something. Sorry, wrong phrase. Send me more Bitcoin. Let's see if our files got decrypted. Cat file.txt. Nope, still encrypted. Let's try it again, but they sent me enough Bitcoin and now they have the right password. Python 3 decrypt.py. Type in coffee. I just realized that I put the print statement within the for loop, so it printed it 4 times. Oh well, who doesn't want to be told to enjoy their coffee 4 times? It still works. So now let's see if it happened. Totally worked. Yes, everything's working. So at this point, you just wrote some ransomware using Python. Now, yes, this is simple. Typical ransomware does get much more complex, but at the bones of it, this is how it works. I mean, this does work. Isn't this scary and also cool? So don't do it to anybody, please. Like maybe as a joke to your friends and family, but like to make sure everything's recoverable and backed up. Just like, but it's fun though, right? It's cool. Now, part 2, as promised, we're gonna download a malware library that we can play with and learn more about other types of malware. Let me show you real quick what it looks like. It's a fantastic GitHub repository called Malware Showcase from this guy right here, Patrick. However you say that last name. And it shows you fantastic usable examples of adware, droppers, file infections, ransomware, spyware, Trojan worms. It's pretty cool. So let me show you how to get it going real quick. All we're gonna do is first, I'll have this link below. We'll copy the link to his GitHub. I'm gonna cd ... into my home directory. Yes, I'm home. Now I'm going to git clone, paste that repository, and just like that, malware downloaded. Now to have fun with this, there are 2 things you got to do. First, make sure you have pip3 installed, which is what we're going to use with Python to install additional libraries. And then we're going to actually install some requirements using pip. So I'm going to do that right now, actually. I'm going to do a quick sudo apt update to update my repositories. And we'll do sudo apt install python 3 -pip. We'll do a -y at the end, and that'll install pip3 for us. Go. Coffee break. Done. All right. Now, if we do an ls, we'll see that we have a new directory called Malware Showcase. Let's go ahead and jump in there. cd Malware Showcase. If we ls that directory, we got a few things going on. Before we play with it, we want to install our requirements, and here's how we'll do it. Type in pip3 install -r and then requirements.txt. It'll go through that text file, look at all the stuff it wants to install, and actually install it. Go ahead and hit enter, and another coffee break.
All you wanted was to add a column while planning your next sprint. Maybe it's time to move to Monday Dev. Here are 5 Monday.
And that should be it. So if we LS that directory, we can jump into each of those. So for example, cd file infection, if I LS that, I can see we have some example target files and target folders, and also an infector.py file, the actual script we're going to run. So if I jump in there real quick, actually, nano infector.py, there's some fancy advanced Python in here using things like classes and functions. But what's cool is it shows you how this kind of stuff works. So you can dissect it and learn it for yourself. And of course, we can run it too. So if I can jump into the README, I'll less the README file. Great README files will tell you exactly how things work. Hit Q to exit that, and then I can run the file, python3, infector.py, and it ran. So I'm not going to show you every one of these. Just feel free to go crazy and play with it. And please only play with it if you're using a throwaway Linux box like we just did in Linode. Otherwise, they do show you how to set up a virtual environment, a Python virtual environment with env. But yeah, malware is crazy and scary and also pretty fun. The purpose of this video was to help you understand kind of how it works and how it's written in code. We got to do some really fun stuff in Python, and we wrote our own ransomware. Just cool. You can tell your friends and your coworkers and your mom that you wrote ransomware today. Congrats. It's a good day today. You accomplished something. Just please don't use it against somebody. This is for educational purposes only. Don't hurt anybody. Don't be evil. Isn't that Google's like what's the word for it? Slogan? Yeah. I don't know. Just don't be evil. Yeah, that's pretty much it. Thanks for learning some malware programming with me, and I'll catch you guys next time. Oh, and by the way, speaking of hacking, have you hacked the YouTube algorithm today? Let's make sure you do. Hit that like button, notification bell, comment, subscribe. You gotta hack YouTube today. Ethically, of course. Yeah, for real. I'll catch you guys next time. If you're using hacking tools like Kali Linux and you're not doing anything to hide yourself, it's kind of dangerous. Like, you could get into trouble. You need to learn hacking. Proxies and proxy chains. That's how you hide yourself. In this video, I'm going to show you how they work and how to set them up in Kali Linux. I also have a crazy challenge at the end, a hacking challenge, using the knowledge you're going to learn in this video. If you're up for it, the first 5 people to complete this challenge will win a 6-month membership to This Is IT and a bag of Network Chuck coffee. And also a huge shout out to IT Pro TV. They're sponsoring this part of my journey. I use them to learn about proxy chains and everything else hacking I've learned so far. So if you want to check them out, if you want to learn hacking, CCNA, A+, whatever, link below. Use code Network Chuck, 25% off forever. So you're ready. You're ready to hack. You fire up Kali Linux. You've got your tools ready. You're ready to hack somebody. Let's do it. You've got your target, David Bombal. We're going to use Nmap to find out more information about his stuff. We'll even be stealthy about it with the -ss command. And boom, we're hacking. And look at that. I got some recon on David Bombal. Do you know what you just did? You may have learned a few things about David, but he also learned a few things about you. All this scanning that you just used to find out about David, his system flagged it. His firewall saw what you were doing. It blocked you. And even worse, he knows it was you, because every scan you send has a from address. A nice little note that says, hey, it was me. I'm doing it. I'm hacking. That's your IP address. And David, now that he knows your public IP address, can report you and you go to jail. But Chuck, I had a mask on.
Summer savings start now with the best price of the season for Corsair Plus. Get 50% off a year of access to over 10,000 learning programs.
Doesn't matter. If you don't do something to hide the fact that all of these messages, all these attacks are coming from you, you're in trouble, or at least are very close to being in trouble. Now, before I show you how to hide yourself, let me tell you this. I'm speaking strictly in the context of ethical hacking, having a business's explicit permission to do this. Anything else, don't do it. There are a few ways to hide yourself, but I want to focus on proxies, and more specifically, proxy chaining. How does that work? With the proxy, instead of sending all of our attacks directly to David from us, telling David exactly who's doing it, hey, it's me, we'll use a middleman, a go-between, a proxy. We'll call these proxy servers. So now when we attack David, we'll send our attacks through the proxy server. And if David does happen to catch on and see the attack, and he goes, hey, who's attacking me? He'll see the IP address of the proxy server. And not us. Now we have to be careful here because what could happen is David would tell the police, hey, someone's attacking me. And the police see the IP address of the proxy server and go, yeah, that's a proxy server. We're going to contact them and find out who attacked you. And the proxy server will have logs that could tell them that, hey, it was actually this guy over here, you, that used the proxy server to attack David, and then you're busted. So what do? Well, let's use some more proxy servers. How about that? Instead of sending our attacks through just one proxy, we'll send it through multiple proxies. Send it to this guy, then hop to this guy, then hop to this guy, and then finally, we're attacking David. This is what's called proxy chaining. We're chaining together multiple proxy servers to hide ourselves. So if David did tattle on us and tell the police, the odds of them going through each of these servers and going through their logs and finding us through all this mess, pretty slim chance. Now, not impossible. This is not a foolproof situation where you'll never be discovered. No solution is. But it does make it crazy difficult. So how do we do it? Let's do it right now. We're going to use an app called Proxy Chains, which if you're using Kali should be pre-installed. All we have to do is configure it. So first we got to locate the configuration file. So here at the command line, I'll do locate and I'll type in proxy chains. Hit that. And the first option up there should be where your stuff is. Yep, right there. Etsy/proxychains.conf. The reason we use this command is yours could be in a different spot. This will help you find it. And this is the file we're going to edit. So I'm going to jump in there. I'll do sudo, and I'll use Vim as my editor. So I'll hit VI, and then I'll put my path in. Etsy proxychains.conf. Now there are three main modes we can run this in, and one we're going to ignore: dynamic, strict, and random. We're not going to do strict, so we're actually going to end up commenting that out with a hashtag. With dynamic, we'll put our list of proxies in. We can have a lot. Let's say we have 4. Dynamic will go through each proxy in our list and chain them together and use it in the order we put them in every single time. Unless one of them is out of commission, not responding, not usable, it'll just skip it. With random, it's random. Same deal. Let's say we have a list of 4 proxies. It will randomly choose one proxy to use, which is fine in a lot of cases because it keeps your targets guessing, like, oh, where's he coming from? Where's he coming from? All these different IP addresses. But personally, I like dynamic because we put a lot of proxies in between us and the target, making it harder to find us. So to make that magic happen, I'll put my cursor there. I'll hit I for insert, and I'll remove that hashtag, which makes that configuration active. And we want to comment out or put a hashtag in front of strict chain, disabling that option. So we got our mode. We're not done yet. Let's keep going. We're going to scroll down. Now here's an option we're not going to touch, but it's good we have it enabled by default, proxy DNS. If we were to comment the setting out and not use it, our DNS request would still be coming from us. So when we try to discover what IP address davidbaumel.com has, that particular request would come from our IP address, let's just say 10.1.0.4, and that could be a way that people find out we're the hacker. So best case is you want to proxy everything, even your DNS request, through your proxy. That way no one can find you. Now as we scroll down, the only thing we have to look at now is our list of proxy servers. And here's the format right here. We have the type, the server IP address, and the port we're going to use. And if it has authentication, you'll put the username password right here. Now you might be wondering, what's with the different types? What's the difference? We're not going to cover that right now. It's a whole other video. Just know that SOCKS 5 is better than SOCKS 4, as you might assume. And in addition to HTTP, we also have HTTPS. So all you have to know right now is these types will help you proxy your connections, help you to hide yourself. Some are more secure, like HTTPS or SOCKS 5. So let's move on past the example and start adding our list. Now by default, we already have something here. This proxy server is pointing to 127.0.0.1, which is our loopback address, which is pointing to us. This default config is actually going to be using what's called Tor, or the onion router. We would have to have this service enabled on our Kali Linux box here. We're not going to mess with Tor right now. Just know it's your gateway to the dark web, and there's a lot of proxies involved. So we're going to skip that for now. So I'll put a hashtag in front of that to comment that out, and I'm going to put my first server in. The type of this proxy will be SOCKS 4, and then I'll put a space between that and the host IP address, and then a space and the port. And that's pretty much it. I'm going to hit escape:WQ to write and quit. Done. So now how do we use it? Watch this. I'll use the command proxy chains. This is what you'll do whenever you want to use your proxies. You'll put this command right before your other commands. So let's try out Firefox. I want to verify this is actually working first. So I'll go out to google.com and let's do it. And we're there. Now real quick, let's go back to the command prompt and see what crazy stuff happened. And it's still happening. We can see here that first we have our DNS request to find out, hey, where's google.com? And we are indeed proxying it through that proxy I configured. And once it learned the IP address of Google, it proxied our connection to Google through, well, the proxy. Now let's go see where we are. Let me get back to our browser. I want to type in first, what's my IP address? So great. The public IP address does match up to the proxy I was using. If I type in where am I, it's going to tell me where I am. And this doesn't tell us much, but I can tell you right now that I am in Thailand. So good luck finding me. So I'm sending all of my commands through a proxy server in Thailand, which is kind of crazy, but also kind of cool. Like, let's try one real quick. Let's go back and hack David. David will never find me in Thailand. So once more, I'll start with proxy chains. And I'll use the nmap command this time. I'm going to use a TCP connect scan. And I'll search for ports 80 and 443 on David Bomble's website. And I'll use the IP address this time. And let's see what happens. Now, how cool is this? Every single command went through the proxy. It went through Thailand to discover if these ports respond. So as I'm pen testing David's site, as I'm doing vulnerability scans and such, he doesn't know it's me. He thinks it's some person in Thailand. And I get my info. Now, this is just one proxy. Let's add one more to the list. I'm going to hit I to start editing, and just below my first server, I'll put my second server here. This one will be HTTP, and then I'll put a space and the IP address, and then the port number, space 8888. Escape, :WQ, and we're ready to rock. Let's make sure it works first. I'll do proxy chains, Firefox, google.com. And okay, looks like it may have worked. Let's do what's my IP. And there we go. Look at that. Let's take a look at our command prompt. Here's the chain right here. How crazy is this? We first have our Thailand chain, and this is actually a server on AWS that I set up, a proxy I set up, and then we're finally to Google. Isn't that amazing? I love that. Let's see how it looks when we use nmap. So I'll do proxy chains, nmap-st for a TCP connect, -p. I'll put ports 80 and 443, and then David Bomble's IP address. Boom. How cool is it? Look at this. It's going through the chain and checking. But how insane is this? It's going from me to Thailand to AWS, which I don't know where that is specifically, to David. How's he ever going to find me? And if I keep adding more proxies, I'm hidden, man. I'm gone. Now, I'm sure you're wondering, where do I find these proxies? I want to try this out. Where do I get these Thailand servers? Just Google them, really. Watch this. I'll fire up Firefox, go to Google, and just type in free proxy server list. And if you scroll down, one good site is spies.one. Now, I'll tell you this. Not all proxies are created equal or will work. So you might have to go through a few and test them. But that's how you would find them. Just Googling and trying them out. All right. Are you ready for the challenge? Check this out. So this is the proxy chain challenge. Here's what you have to do. First, you will need Kali Linux to run this. You'll do exactly what we demoed in the video today. And the challenge here is that you have to use all 3 of these proxies to get to this web server right here. And this is another use of proxies. You can use them to hide yourself. You can also use them to gain access into other networks, which is what's happening here. Now, you must use all 3 proxies in this order in your configuration file. Why? Well, because you can't access this proxy directly right here. You can only access it from this IP address. You can't access this proxy directly. You can only access it from this IP address. So once you have your proxy set up and you have all your traffic going through these proxies, you'll get to here where you have to find this web server. This web server has a private IP address in this range right here. The only way you can access these private IP addresses is by going through all 3 of these proxies. You'll need to scan this subnet using nmap to find the right host that has port 80 open. Once you've identified which host has port 80 open, then you'll need to access the website. And of course, you'll have to access it via the proxy chain. It's a private IP address that's only accessible through the entire chain. And on that website, you'll have further instructions. Now, a hint on the nmap stuff right here. None of the hosts in this group will respond to a ping. And you may recall from the nmap video that nmap will initially send a ping to make sure the hosts are up before attempting to see which ports are open. So you'll need to make sure that nmap isn't going to ping and do that check. To avoid that, we'll use the switch uppercase P, lowercase n. This will avoid the ping, the initial ping to see if the host is up, and just go for the TCP connect. And that's what I would do. I would use the TCP connect -ST, lowercase s, capital T. And of course, you got to use your proxy chains, otherwise you'll get nothing. Okay, to sum this up real quick, you're going to configure the proxy chains I just showed you in your proxy chains file in Kali Linux. You'll then use nmap and proxy chains to scan the private IP address range of 172.172.32/29. And you're looking for the active web server that has port 80 open. Once you identify which host that is, access that website through proxy chains. And on that website, you'll find the next step, the further instructions. Good luck. Only 5 winners. Well, guys, that's about it. Let me know what you think of this video. If you like the challenge, let me know if you complete the challenge below. I set this up in AWS, and I hope it doesn't break. It was fun to make, though. Any comments or questions, let me know below. Again, huge shout out to IT Pro TV for sponsoring this part of my journey. I encourage you to check them out if you're looking for IT training. Okay, proxy chains, gotta keep yourself safe. I'll catch you guys later. Password hacking. In this video, I'm going to show you how to hack into a server by cracking its password. And this is real world. You'll get a chance to do this yourself on my server. Also, this is for educational purposes only. Please don't go hack somebody else without their permission. Only hack me. You need to learn hacking. Okay, the goal here is to hack into this server, the coffee server. Why? Well, because once we do, we get free coffee. Coffee's awesome. Although you might need coffee for this, so go ahead and get it. Now, the good news is that we already have a username. The username is Dwight.Schrute, which is a great start, but what we don't have is the password. This is our mission. We're going to hack Dwight Schrute's password. And when I say hack, I also mean crack. Oh, and by the way, this is a real server that I want you to try and break into. Watch until the end. I've got a challenge, and the first 5 people to complete that challenge will win free coffee. Legit. All right, here we go. Oh, and also a huge shout out to IT Pro TV, the sponsor of this video and my hacking journey. They're my primary learning source for learning things like this. So if you want to dive deeper, check it out. Link below. If you use my code NetworkChuck, you get 30% off forever. So yeah. So how do we hack this password? How do we crack it? Well, we can do it the old-fashioned way, right? The good old Dwight Schrute method.
Try 000-000. No. Okay, now try 000-001.
SSH Dwight.Schrute at my host. And I just start trying passwords. 00001. No, let's try it again. 00002. No, that's not right. Let's try it again. 00003. Oh, let's try it again. No, why would you keep doing that? There are better ways, and we can even automate this process to make it killer. Check this out. So what we were just doing is traditionally called a brute force attack. We were going to sit there and try every password under the sun until we found out Dwight's password, even if it took us 5 years. Not the most efficient use of our time. Now, to be fair, every attack I'm going to show you is technically a brute force attack, but we refer to them in different ways. But there are so many better ways, and we're going to open up some hacking tools right now, and they're amazing. Check this out. The first tool I want to show you is called Hydra. So fire up Kali Linux, launch your terminal, and we'll get going. We're going to use Hydra for an online attack, which basically means we're going to be trying our passwords on a live system. We'll be entering those passwords in the prompt and getting denied as we keep trying them. Now, Hydra is going to do all the work for us. We'll enter our command in, step away, and done. But she's not going to do what we just saw, just trying every password under the sun, 0001, 0002. No. We're going to give her a list of passwords that we think might be it. What we're doing here, providing Hydra with a list of passwords, is called a dictionary attack. And this is crazy effective because it has a list of common passwords that a lot of people might use. And we have a lot of passwords at our disposal. One list we have that's already built into Kali Linux is called the RockU password list. This company, RockU, got hacked back in 2009, and these hackers released all their passwords they found, which were stored in plain text. So now we get to use it. And this list is massive. Let's take a look right now. If I open another terminal here, if you're on Kali, you can find it in user share word lists, and there it is right there, rocku.txt.gz. And we'll just unzip that real quick. Sudo gzip-d, the file name rocku.txt.gz, and let's take a look at it. I'll cat the file right now. Look at that. So many passwords. I better stop it before my computer has a heart attack. There we go. Now, I will not be using that list. That list has 14 million passwords. But I do have my own list. Here is my word list. Things I think Dwight might use. So let's try it out. First, I'll specify my username. Now I could do -L to specify a file name like usernames.txt and look through a list of names. Now I already know it's Dwight, so I can just do a lowercase l and put in Dwight.Schrute. And then I'll specify my password file. I'll do -P and my file, which I have named wordlist.txt. I'll do a backslash to move to the next line here. And then my host, which is 45. Blah, blah, blah. And then the service type. Right now I'm accessing the server using SSH. So I'll specify SSH. It could be FTP, it could be Telnet, whatever. And let's go. Oh, password. It's all about passwords. Bam. You see how fast that was? I mean, the list wasn't big, right? But it found it. Check it out. Here's the password. Bears Beats. And went through my list, tried each one. This is the one. Now, this method is fun and useful, but let me tell you, if you're trying a bunch of login attempts, a bunch of passwords, firewalls might find you. You might get blocked. Plus, you have timeouts. The account probably will get locked out. Not the best method. But we have another way, a better way. Check this out. Let's take our password hacking from online to offline. In this situation, we're not going to try and log into the server a million times. But how does that work? How do we know if it's going to be the right password if we can't actually try it? One word, hashing. What is that? Let's talk about it. You see, when Mr. Dwight Schrute created his password, Bears Beats, the server will take this password and store it in its database so that when Dwight logs in, they can go, oh, that is Dwight's password. Come on in, Dwight. But they don't store it like this, in plain text. Like, you won't log in and see Bears Beats. It won't be there. Actually, let me show you what it looks like right now. On that server, it'll look like this. This right here is Dwight's password. This crazy mess of numbers and letters is called a hash. So when Dwight created this password, Bears Beats, the coffee server hashed it. Basically put it in his mouth, chewed it up, and blah, spit it out. Looks like this now. Now, it's a lot more complex than just chewing it up and spitting it out. Blah. For the server to turn Bears Beats into this, it uses these crazy hashing algorithms, which, without getting too in the weeds on it, is just a crazy math problem function turning it into this. You might already be familiar with some of the hashing algorithms out there. Popular ones are MD5, SHA-256, you got NTLM on Windows. And if we were to somehow hack into the server via other means and get a list of all the username and passwords that look like this, it would do us zero good, no good at all. When Dwight logs in and he puts his password in, Bears Beats, the server takes this password, chews it up, spits it out, or in this case, runs it through its MD5 algorithm. And if the hash matches the hash stored in its database, you can go in, you're good. This should be how most websites and services out there are storing your passwords. Not in plain text, like the RockU server. No, it's hashed. So if they do get hacked and hackers get that list of usernames and passwords, they don't have your password yet. Here's what we can do. We may not have Dwight's password, but if we have his hash, if we somehow got that information, we can do some offline password cracking to figure out what it is. Now again, we can't reverse engineer it, but we can brute force our way into it. We're going to do what we did before. We're going to take our word list and we're going to try and use each of these passwords. But instead of trying to log into the server, we're going to run that hashing algorithm. We're going to chew it up and spit it out. We're going to run that MD5 algorithm and see if it matches the hash we have for Dwight Schrute. So we'll take the first password, Salesman of the Year 3, run it through. It looks like this. Doesn't match. We move on. We try password 123 and we get this. Not a match. We move on. And we keep going until we find a hash that matches. And we'll try Bears Beats. And boom, this one does match. A+. Let's go. We got the password. Let's hack into the system. Let's do this right now. Okay, here in Cali, we're going to try out a tool called Hashcat. For this tool, we're going to use two things. First, our word list, our list of possible passwords. And two, we'll need our file of hashes. Let's go ahead and create this real quick. Linux will store its hash passwords in the shadow file. So I'll grab that right now. And I'll just create that file. Paste all that stuff in there. Save that. Now let's crack a password. The command will be sudo hashcat. Now, real quick, hashcat's pretty crazy. You can do a lot of stuff. I'm going to show you the basics real quick. First, we'll start with the method, which we'll specify with -a. Let's go to the manual page of our hashcat real quick. So we'll open up another terminal window and go to man and hashcat. A lot of stuff going on. Let me scroll through to where I'm talking about. So we used -a, and here are the options. And if I talked about every one of these options, this video would be like 4 hours long. So I'm only going to talk about option 0, the straight option, which is just going through a word list and doing what we just talked about. These other options, which I would ignore, brute force, but combination, hybrid word list and mask, hybrid mask with word list, it's some crazy stuff. It's not just going through a word list, but it's auto-generating these crazy password lists and these password combinations and what password characters you can use. It can be intense, and perhaps it's a video for another time. For now, we're going to talk about just a straight dictionary attack, option 0. So we'll put in 0. Now next is our hashing type. We'll put in -m to specify that. Let's go back to our man page. Here we have our hashing types, and there's a lot, a lot of hashing types. And it's going to be based on what type of password you're trying to hack. For example, if you know you're going to be hacking Cisco, Look at that. You'll enter the code 5700 in that option. For a plain Jane MD5, it'll be 0. 1000 for NTLM, which if you're hacking Windows-based passwords, that's what you'll use. And for our example, we're going to be using 1800 for SHA-512 Unix passwords. So we'll put in 1800. I'm also going to throw in a dash lowercase o and specify a file name, crackpasswords.txt. This is where it's going to store the information we find out. And then finally, the two files we're going to be using. The first will be our hashes, which we named hashes.txt. And then our word list we're going to use, which was wordlist.txt. And that's all we need. Hashcat's about to spit some words out. Let's do it. Here we go. And dadgum, that was fast. Now again, the word list was not that big. And it found the password. If you look here at candidates.number1, it gave us two options, Eminem and Bears Beats. Now we know that Bears Beats is the correct password, so great job, Hashcat. Now let's try one more. Let's try a Windows-based password. I'll do sudo hashcat once more and do a -a and specify, oh, not -1, -a and specify my method, which will be 0, -m. This time I'm doing NTLM for Microsoft Windows. I know this to be 1000 as the code by looking at the manual page. I'll do a dash lowercase o for cracked passwords.txt where I'm going to store my stuff and then my hash. Now I could specify a file. This time I'm going to specify the hash. I'm just going to copy that in there. So I'll just put that in quotes. So I got the one hash I'm looking for, and then I'll put my word list in right here. Wordlist.txt and go. Now it's a bit wonky because it says the candidates right now are Bears Beats, which I know is not the password. But if I go to the top here, it says the session status cracked. It said it did it with this hash. Let's go look in that file we put that in. So I'll sudo cat crackpasswords.txt, and let's take a look inside there. There it is. Okay, perfect. There's the hash I used, and there's the password for my word list that we matched up. And that was indeed the password. So now I have a challenge for you. I want you to use the skills you just learned in this video to hack or crack my server's passwords. The first 5 people to do this will win coffee. So link below. Good luck. And if you don't win, that's fine. I'll keep this challenge up for probably a week or maybe 2 weeks.
All right, so look. This checks if a given string is a palindrome. And palindromes or mirrored strings appear in malware signatures or pattern recognition tools. This demonstrates string comparison via symmetric analysis, highlights data normalization and cleanup. As far as this part, the reverse engineering payloads are obfuscated scripts. Malware authors often reverse strings to hide URLs. Commands of PowerShell code useful in capture flags, where reversing encoded payloads is common. Demonstrates how data flows in and out of memory in reverse. Malicious stack command simulator. Simulate the stack options like push, pop, peek, integers. Mirrors how stack frames work. Function calls can be expanded to simulator for secure command execution where each operation is logged and validated. Think of a hacker overflowing the stack with carefully crafted instructions and lets you visualize how stacking and popping works under the hood. Alright, cool. We're gonna definitely do some more tomorrow, man. Day 6. Smooth little session. You feel me? Got some good work done, man. So I'm gonna catch y'all boys, man.